All right. Good afternoon, everyone. My name is Tyler Jewell, and the title of this talk is Using SaaS Developer Environments to Develop Apps Faster. I'm pretty pleased to be here. I'm from San Francisco, and I am the founder and CEO of a company called CodeEnvy, which is still a fairly new and young company that hasn't come onto the market. And we asked to come here and sponsor the event so that we could introduce some new technology that we've never demonstrated before. So with any luck, we're going to introduce some concepts that we've been working on, take you through some demos, and try to present a different way for doing development in the future. So we're pretty excited by it. A little bit about myself. I'm a venture capitalist as well. I'm a partner at a company called Toba Capital. We invest in enterprise software companies, about $700 million in our fund. I only invest and work on development and developer infrastructure related businesses. SaaS Labs, WSO2, Zero Turnaround, they make the JRebel product, InfoQ, SourceGraph, some cool companies and businesses that are out there. I'm also a member of the Eclipse Foundation, just joined their board, and the project lead for a project called Eclipse Flare, which we'll talk a little bit about, which is a new project there, which is going to be based on cloud development. So, first of all, before we get into this, how many people have heard of CodeEnvy before? Okay, like a handful. How many people have heard of Eclipse Orion? Another handful. Cloud9 IDE? Different handful. Like no two names are the same. Nitrous IO? Okay, roughly small number of people there. How many people in here, is IntelliJ their favorite Java IDE? A lot of hands, right? Eclipse? A couple of hands, all right. I use IntelliJ and Eclipse myself. And what's interesting is I think most Java developers do. They have a very strong bias to the tools that they make use of. Let me ask you this. How many people in here are familiar with Docker? Just a couple of hands. It just went 1.0. It's a very popular technology. We'll talk a little bit more about that. Okay. Interesting. Okay, so a little bit about the background of where we come from. CodeEnvy and some of the technologies we started working on began in 2009. And it was a French company called Exo Platform. They had this content management portal, and they had built some multi-tenancy IP for the JVM. And they said, hey, we'd like to find a way to test this out and do it something in high parallel and high scale. And so they wrote a browser-based IDE that created open social widgets for their platform. And they put it out there, and they got 200 visitors, and they were like, oh yeah, this is awesome. And the people who started using it, they said, this is really interesting, but it would be great if you could add Java support. And they did that. And then they said, it would be great if you could deploy to Google App Engine. And they did that. And slowly but surely, through word of mouth, they got to about 10,000 users. And in 2011, this word of mouth was starting to get going. And they realized that the system that they had built was all wrong, and that it was too slow. If you've used some of these browser-based technologies, you found that they're incredibly slow. The security model wasn't right, and we'll talk about what that means. And they certainly weren't extensible enough. When you go and you use these browser-based IDEs and you go and run something, they tend to use a Cloud Foundry or some other sort of infrastructure as a service to provision a process for you to run your application. And that provisioning time is such a burden that it made the system so slow that it was unusable. And also, they were just not extensible. If you wanted to launch a container inside a Cloud Foundry, you have to have the cartridge pre-formatted, pre-compiled, and then you still have to wait for the overhead of the boot. And as developers, that's just unacceptable to us. We need everything personalized. So what we did is we took the little IP that we had, and we threw it away. We created a new company called CodeEnvy, and we raised $9 million of capital, and we promptly grew our engineering team to 40 people. And we're now 50 people now. And for the past 3 years, we've been rewriting everything, and we've got some concepts that we want to throw out there today. So quite a few number of people. It's quite a significant system, and I'll walk you through it. The next thing that we're going to be talking about is we're going to open source all of it. here, and we started the process. It's going to be made as a donation to Eclipse. And we're going to, assuming everything gets approved here, and we don't see why it won't, that CodeEnvy plus the Eclipse Orion project are going to come together into one big top-level project called Cloud Development. And we want to change the nature of conversation. And we actually think that, given enough time and given enough technology, that cloud developer environments can actually be faster than do-it-yourself configurations on the desktop. And I know that's blasphemy, so let's just kind of get right into it and why that's the case. So there was this interesting study done about a year ago on LinkedIn. It was with 1,200 software engineers. And they were given an interrogation of how they spend their time in the week. And there was this really kind of funny statistic that came back, and they said, on average, developers spend about 13 hours a week configuring their environment. Now, this is not downloading and installing the tools that are there. It's switching between branches. It's dealing with commit IDs, change sets. You have to update your tools and plugins. You have to deal with hardware interoperability, long debug cycles. And so there's this overhead tax that has started to materialize. And as you get up to the team challenges, you start getting into situations where you've got tribal knowledge of the environment. So you might have a team of 6 people, and 1 or 2 of them are really experts at configuring the environment, and the other 4 are just kind of following the wiki page along the way that they go. And so that's a drag on the productivity of the team. You get environmental debt. So as a project ages out, if you haven't made that environment current, when you go back to revisit it for a bug or maybe a QA cycle that you need to do, it gets harder and harder to reconstitute that environment and get it to a point where it's ready to compile and run again. And then there's time tracking. If you have offshore development or nearshore development, and you want to understand exactly how much time we spent per issue or per bug or per developer, there's no real simple way to do that automatically. And then at the corporate level, you get into situations where you have IP security risks, that once you've cloned the code and put it onto your desktop, there's not a record of what's going on with the IP, and that's a problem for certain large organizations. So development configuration today looks something like this. And I love this because this is the basic tutorial, the quick start tutorial for installing Tomcat 7 with Eclipse here. The non-quick start version is about 3 times longer than this. And so, I think with most development organizations, and even our own, we have a wiki page, and we use Confluence from Atlassian, and you go onto that page, and 50 steps later, if you follow everything and all your credentials are just right, you might have a working development environment. And and as time has gone on, we've had these manual configurations that people follow, but we've also then gotten to the point where you get Vagrant. Anybody here use Vagrant or Boxen from GitHub? Quite a few hands. Okay. So what Vagrant does is it will basically provision a VM locally and execute a recipe. And in theory, everybody follows the same Vagrant box. You can get an identical copy. But even then, you've got to deal with some issues because now you've got a guest OS versus your host OS. There's going to be some interoperability issues there. So even though it can automate maybe 80% of the workflow, that last mile is still quite problematic. So we used to talk about ourselves as a cloud IDE, and if you go online and use our production system, that's exactly what you get. But we think that was the flawed model. There were, if an organization is going to use a system like this, it needs to be completely automated, completely extensible, extremely fast, and very secure. And so if you stop thinking about, okay, the value of this is in the IDE, the editor, and the tools that I get, it's more about the provisioning. What it is it's about being a developer environment cloud and less about being an IDE. And so what a developer environment cloud does is it first allows you for instant provisioning of a developer environment. So you shouldn't have to download anything. You shouldn't have to install anything. You shouldn't have to maintain anything. And it should be complete and comprehensive, meaning the environment has the project, the code, the SCM tools, the editor of your choice, the code assistance of your choice, a builder that includes a compiler, a packager, a unit test system, A runner that is recipe-driven and configured exactly to the needs of that project. So it has the frameworks, the app servers. If it needs a JVM or some sort of other language runtime, it provides that. A deployment system, the connections to your ALM tools, whether it's Jira or Jenkins or whatever tools that you've got in-house, and then any tooling plugins that you've got to make your development code more productive. So if that's your definition of the environment, then a developer environment cloud is one that allows you to provision it quickly through an API. Then if you do that and you expose the interfaces the right way, then you can use any of your favorite IDEs with it because the interactions with this system are well defined. So you can use Eclipse, IntelliJ, or since it's well defined, you can provide a browser IDE as well on that. And since the interfaces are well defined, you can integrate it with your existing processes and tools, and so that it can become part of that. When you can make provisioning instant, instead of each developer thinking about the environment that I have, you can now have an environment for every task. So you can associate a task to a Jenkins job, you could associate a task to a Jira, an environment to a Jira, you can have one for yourself. So when provisioning becomes frictionless or with no tax, the number of environments you can have goes way up, and the utility of each one actually goes way down, and you can use them either in a throwaway capacity or on-demand capacity. Once you have that, then it needs to be dead simple to clone it, embed it inside of other products, or share the same one with multiple people, right? And then obviously access controls, whether they're behavioral or read-write based, need to be inserted in so that you can secure the environment and quarantine it. You then need to be able to scale the environment so that there is an orthogonal way to add CPU and RAM so that environments that don't need a lot of resources can stay small, and environments that do need a lot of resources can go large. And then you also need a development PaaS cloud that can run these environments at scale so that you can have the maximum amount of developer population with the minimal amount of hardware, right? So you want to have a density efficiency that's there. Then you can manage it, analyze it, and extend it. So this is kind of what our vision of a developer environment is. And the way we've dealt with the provisioning problem is this thing, we call them factories, you can call them cloners, copiers, but essentially it's a URL, right? And inside the URL is a recipe for everything that the developer environment needs so that once the provisioning process is done, you should be able to compile and run. So let's do some demos here. And let's hope that since this is the first time we're showing this publicly, that Murphy doesn't get in the way, shall we? All right. Great. So command line, is that readable in the back, by the way? Yes? Okay, good. So first thing is that I'm going to run this CLI, and it's going to go to one of our servers and grab a JSON file. These JSON files have essentially configurations of entire developer environments here. And it prints out a URL, and the URL is going to one of our providers, and it's got a factory, so it's a factory generator, and then there's a bunch of attributes that come after it. I'm going to hit launch there, and in the background it's opened up my browser, and it is creating one of those environments right now. I'm going to copy this URL. Oops. Yeah. Let's just launch a couple of these. And just for fun of it, I can take the same one, launch it, and assuming that the Wi-Fi connectivity doesn't go berserk on me, what it's doing is it's going and creating a temporary environment. And you can see that the original URL is now different, and it's got this ID of a temporary workspace here. So it's gone, it's taken the recipe, and it's created an environment. And inside that environment, it's cloned the code. It has opened a file. There are some post-load actions. This is our legacy system that's here. We're just showing this for the example. But if I come over here to the other tabs that I launched, I took that same factory, launched it 3 times, and I'm getting 3 completely different temporary environments. What makes it temporary is that if I go idle or I close the browser tab, I lose my work, right? And if at any point in time, you can copy it to an account, and then you're going to get persistent storage indefinitely. So a temporary workspace is essentially a hack space. It's a throwaway space. It's everything that you need. If I need to, I can come in here. I can do project build, and it's going to build, right? No problem with that. So let's go back here, and let's do, let's see. Let's look at some of these other ones. All right. So all right. I'm not activated my environment. So here's another one, and the file that I'm converting into a factory is here, and you can see that it's a JSON file, and inside the file are various properties that tell me about where the source code should come from, which commit ID off the branch, is there the action means what should I do with the project after I'm done. Some meta information about it. Do I want to have a file that opens? And project attributes. What type of project is it? It's a jar project. What the project name should be. So this time I did an encoded version of that, which stores it on the server, stores the configuration, makes for a shorter ID. Oh, we're getting these 408. I've been getting 408s here. Something about the Wi-Fi. It's a bummer. And it's launching another environment there. All right? Another 408. That is not right. Okay. All right. Well, don't worry. We got other things we can do. So that was the foundation for that. Now, what we wanted to come and show is when we started rewriting this, we realized that in order to have total extensibility, there was a couple of things that needed to happen. The first is that, one, a developer would need to be able to extend the functionality of the tooling set in any way, shape, or form. And in order to do that, the system was going to need to be authored in such a way that was similar to the Eclipse RCP or the IntelliJ core runtime. And so what we did is we rewrote our product, and we'll just go full screen there. And so what we did is we wrote it using GWT, and at the lowest layer there's this kernel, and it's a very lightweight kernel. And you can write extensions, and I'll show you what extensions look like. You write them as single Java files. And when you are done with that Java file and you compile it into the kernel, it breaks it into 3 parts. One, there is server-side logic that represents the business logic that you need for the extension. It generates a RESTful API interface, and then it will also create cross-browser optimized JavaScript as well. And that cross-browser optimized JavaScript will go into this screen window here. With the redesign that we've done, we've focused on speed and performance of the IDE itself. You can see we're inspired by both Sublime and IntelliJ that's out there. I'm going to open a project. Here we go. Get a source code. Open. And this is all running in the browser there. It was automatically provisioned. you can do interesting things like autocomplete, right? And so it's processing, and it's taking a long time, and the reason being is it's got to go and generate the abstract syntax tree on the server, download it here, and then cache it in the browser. But if I were to repeat that operation, it's nearly instant, right? Because now once it's cached in the browser, there's no need to go back and hit on that. It can be smart autocomplete, as you would expect. And there are other features in here, like refactoring for methods and classes. There's code folding, package views. You've got an outline view as well on it. So really interesting stuff, right? It's getting to the point where it can be near fast enough to replicate your desktop-based experience. And there was no install, and it loads pretty fast in that sense. Where this gets interesting is how does the build and run work? So save that. So what's interesting is if you've used some other cloud IDEs, what they typically do is when you provision the environment, they provision a dedicated VM for you. And they put the user UI as running as a lightweight Node.js or a lightweight servlet container inside your VM. They put your files inside the VM. And then you have to install all the tools that you need. They give you root access. You log in. You then install, either using sudo or some other command line utility, the tools that you need. And then you can compile, and then you can run. The problem with that is that it doesn't solve the configuration nightmare that's there. It still puts too much of a burden on the developer to basically manage these VMs. The other problem that creates is that you get a ton of thrashing. When you use one VM and you have to run your IDE, the builder, and the runner all in the same environment at the same time, it's an inefficient use of the resources. So it actually makes a lot of sense if you were to separate different development functions onto different physical nodes and then have the system orchestrate the coordination back into the UI. And that's exactly what's going on here. So behind the scenes, we actually run separate clusters of hardware for editors, code assistants, API, data source management, builders, and runners. And so as a result, you can get high degrees of parallelism for these common tasks, which makes the developer experience overall feel very fast. You can actually have these processes running in the background. In this case, I did a build. It completed a Maven build there. We can come over here and do a run. And it's going to launch the runner, and the runner's running on a completely separate node that the build was running on. And it's going to give us a VM access once it's booted. How do I get a... There we go. So here's a Spring app. So hello, Tyler. And it's there. Right? Since it's running on another VM, you still get terminal access here as well. Oh, it wants me to... I don't have the login. It should just log you in automatically. It's not going to like that. All right. Sorry, I don't have the right password for that. But the shell access is there as well. Getting into some more of the more interesting elements of what's going on is you can start to do interesting things like having post-load actions automatically trigger. So this is someone else's workspace. It has a basic chef recipe going on in it. And one of the actions that was loaded, it said, go ahead and run the application after it was loaded. So I clicked the single URL, and behind the scenes, you can see, there was a couple of things, and it said run the app. And I haven't clicked anything, but the application's already building itself. And when it's done here, it's going to pop up and give me a URL that's available to run that app. Let's bring up another one. Another interesting thing is the runner itself needs to be recipe-based. And so what we mean by recipe-based is that for every project, you may have a very particular type of configuration that you require. You might need a JVM version. You might need an app server that you need to select. You might need different web frameworks and for different particular versions. You might have command line properties that need to be configured in just the right way. So using a traditional PaaS is actually not sufficient because those PaaSes, they try to constrain the configuration of your runtime, and they want every application to fit within that very same constraint that's there. And when you're doing development, you need the ability to make changes very quickly, save those changes, and have that environment reflect that. That's essentially what we do when we're on our desktop, and it doesn't make sense when you do it in the cloud. So along those lines, we use Docker underneath, and what Docker does is it's a lightweight container technology. It runs inside of the Linux process. It allows you to set a recipe so that you can configure exactly what the runtime will look like through a set of commands. And the commands are very bash-like. And this is a Docker recipe here. And essentially what this is saying is, hey, go and grab a CentOS chef image, add this file into the temp directory, and then run this command line command. And so this is going to create an image and execute some commands in there. And if I were to go run, when I hit run, it launches the runner. And in order to get the runner going, what it actually does is it puts the request on a queue. There are these slaves that are processing it off the queue. And it actually did run it there. But if I wanted to come in here and just add another command, and let's say we'll cat that very same chef file. If I were to save that, and in this file, let's say hello world devox, and I were to rerun this, it's going to detect that the Docker file, the recipe itself, has fundamentally changed. And so as the runner gets going, you're going to see the Docker output of it constructing that image on demand right here. There we go. So you can see that it removed the previous one. It run through the commands. And at the very bottom, I get the output, which is the cat on it, which was the modified Docker file there. So now you can take this and start doing more interesting things with it. So we'll just go to our general demo site, log in. Create a new project. And let's create a Java Maven GUI project. Devox demo. Right. I can come in here and run. And in this case, this is actually a desktop app running in the browser. And so we've got a Docker recipe here that not only launches the right environment, but it also installs a VNC client so that you can run the Swing app here. So this was Hello World, right? And it's a Swing app running as well. So it's happening on the remote browser that's there. And so you get powerful mechanisms that come with that. I could actually come in here. I can create a different type of project. Let's create a Spring project here. Devox 2. And it's updating the dependencies. But now I can come in here and start doing interesting things like let's customize the runner. And so, because it's all cloud-hosted environments, either the community or us, we can make sure that every version, every type of application server and JVM is out there as well. So if I wanted to, I could come in here, select Tommy E as my app server, and when I hit run, behind the scenes, we dynamically construct a new Docker recipe right? That that accordingly will construct an appropriate image. And in the case of Tommy E versus Jetty, where the WAR file needs to go differs as well. And so all those parameters are handled behind the scenes. And so you can get something that didn't work. Why didn't? That's not very good. Let's see. Stop it. This is the Devox 2, right? Yeah, Devox 2. Let's do a custom run. Tomcat 7. Is there any errors? No errors. No, there's Murphy. You can't get through a demo without that working, without that happening. Other things that the system can do that are halfway smart when you get into the cloud is it can be smart about caching dependencies as well. Let me just copy this. We can go into the pom.xml. Actually, before we go in there, we'll go in here, and if I do an import control space, you can see that it's processing the syntax tree, grabbing what is appropriate here. Internet connection matters. Like at home, where I have 50 megabytes, this is instant. Is there a wired connection? No purples. All right. Ah, there we go. Okay. All right, so you see that they're all COM. The first things that come up are COM, right? There. So I'm going to save this, go into the pom.xml. We'll lower this. We'll come in here, add a dependency for jcommander, save it. Right, I can update dependencies. And so what's happening is it goes out, checks the cloud-based dependency management system to see if it's there. If it's there, it grabs it and downloads it and puts it in your local environment. If it's not in our central repository, it goes out to the internet and grabs that. And once that is done, you can start to see things. I come over here. You can see that the buse.jcommander has showed up, right? So you can do smart things with dependencies that are entirely in the cloud. Once you have environments like this, part of the whole purpose of this is to make the configuration pane go away. And so there's no point in keeping these environments entirely to yourselves. So once you have these, you can make some edits, you can work on a project, you can get it just right, and then you can generate a URL and put it in one of your social components or email it. I can copy it here, and then now I've got a factory, I can send it to my friends, and they get an entire clone of the entire environment that you had as well on that. So single-click cloning and embedding is important as well. All right, let's clean up some of these tabs. We think this can go pretty far. So because it's just easier to let the video speak for itself, this is an Eclipse plugin that we've built to interact with CodeEnvy as well. And so in this case, it's for the offline scenario. So you have projects that are in a workspace that are out there. And what they're doing is they logged in, it downloaded all the existing projects from the workspace, and then they become available locally, including all the files inside of the Eclipse IDE. It'll store your Eclipse credentials in secure storage there. You can revisit it and import as many projects as you want, and then you're able to edit them locally here. You can then choose to use your local build and local debugger, or you can use the remote build and the remote debugger from a particular environment that you've set up as well. So if you have, so what he did is he ran the build, and the build output streams right back into Eclipse, even though it's running remotely there. And then the same thing on the runner configuration. You can do a run as, you can run at CodeEnvy. In this case, it's on the queue. He's waiting for an environment slave to spin up. And once it becomes available, it'll process the request. If it needs to, it'll construct the environment completely dynamically, launches Tomcat, and there you go. You can get the output that is running remotely back into Tomcat on that as well. So again, the system doesn't have to use the browser IDE that's provided. You can use any IDE that you want. To emphasize that, I bring up here, we've got this set of APIs. I think we've built about 150 of them here that represent each of the atomic components of a developer workflow. So you can actually write clients that trigger remote builds, write clients that trigger runners, manage instances, all of that through RESTful interfaces that are here as well. Okay. This one's interesting. This is MuleSoft. Which one did I launch? I launched it on Market. So this is the MuleSoft API console. And so I launched a factory. This is a JavaScript project. And notice that, I haven't clicked anything inside, and the system's basically going berserk, downloading the internet. And so the system's smart enough to automatically determine the dependencies that are there. It's going off and getting all these NPM dependencies, and it'll take its time to go and build that. So there's a lot of automation that you can bake into the builder system that's there. All right, we'll leave that running for a second. All right, what is... Okay. All right, it's still going. All right. So while that's loading up, one of the other things is to show the richness of the plugins that can be built. And so this was done by a company named Surly. They're a French company. This connects to a data source. In the case of this, we have this MySQL data source. I can select it. I can edit it here. We've integrated with all these different cloud databases that are out there on a SQL level. And you can map your connection. You can test the connection. You can see that it's working here. And so then, you can have your data source, and you can, navigate the schema and investigate the values of the properties. You can even come back into the Explorer. We can do a file. We can do a new SQL file real quick. We'll do devox, hit OK. Right, and then you get completely different editors. Right, so it doesn't have to be a purely text editor. In this case, it's a SQL editor. So I can do select star from, hit control space, and get a completely different type of autocomplete system. There, control enter, and it actually uses the same threading system and slave system to send that request off to a queue. It processes the queue and get a result set back. Right. It looks like our dependencies got done finally, so we can hit run. It ran right away, and it shut down. Why is that? This is where I need some really great humor. All right. Run on a different server. All right. We'll get that one going again. Here we go. And one other example of editor flexibility. This is an editor being built for WSO2, which is an ESB. And again, this is a non-text editor. It's drag and drop inside the editor itself. And you can do things like draw lines here as well. It's not the prettiest thing right now, but you can see the potential of where this is going. And again, this also can be initialized. And then once you have that initialized, you can have the share and copy it and clone and go, and you get a complete copy of that. All right. So, lots of interesting stuff. Let me summarize and show you some of the extension stuff and why we came here. There we go. So these environments, when they're in a full production environment and it's tuned correctly, the stuff that they can be incredibly fast. In some cases, you can do things faster in the cloud than you could on the desktop. Particularly when it comes to switching branches, changing project types, having multiple projects open at the same time, and doing parallel processing on that. So, and the speed benefits come from really two things: parallelism and caching. On the caching level, there's multiple ways that you can cache clients or to offload processing using REST APIs and the server that's there. In the parallel processing, because you can take each of the independent functions and throw them off to different physical nodes, you can now scale build physical activity apart from run physical activity and code assistance using different algorithms. We did a hackathon on our old generation system at Intuit about a month ago now, and there were 4,000 engineers, and they were all on the system at the same time. And so it took us about, I think we had 18 medium-sized Amazon nodes to service 4,000 developers all at the same time. So you can have a really strong reduction in the overall cost on the CapEx if you're looking to manage entire populations. This sort of system, since it's also centralized, you can do intelligent caching with the dependencies that are out there. You can also start adding in parallelism. So you can give a single developer multiple queues, so they can be having 2, 3, or 4 builds running off their same environment at the same time without those builds impacting each other. And the same thing on the runner basis. You can launch and run multiple runners. You can either then shut those runners down or have them in an always-on configuration so that they're there almost as like a type of staging server there. Where this goes from a security perspective is because the system is completely orchestrated, you can track events and insert behavioral hooks into any part of the workflow. So it allows you to actually come in here and you can say, look, I don't want anybody in China to have access to the Git workflow. So we're just going to disable the Git plugin for everybody in this region, and when they authenticate under those credentials, or we can pick up that particular IP address from a geographic determination, we can just reconfigure the developer environment and disable those types of SCM actions directly on that. And so that allows the system administrator to start applying corporate policies to either restrict access or to institute best practices. We've talked to a number of organizations. They come along and they say, hey, we have a very complicated system. We have really very hard challenges in doing merges because our merges are part code, part binary, and so we have to follow a very particular merge sequencing in order to make sure there's no conflicts that occur. And so with a system such as this, you can actually write that logic in through a plugin, and you can enforce that workflow upon everyone when they do a merge and a commit as well. So there's a lot of security and best practices benefits that come from it, and a lot of that starts to come from the extensibility. And on the extensibility side, we have SDK development. So it's a Java class authored with Java, JuiceGen, and GWT. You can use both Java and JavaScript debuggers with it. It's compiled and packaged using Maven, unit tested with JUnit, and then it's lazy loaded JavaScript, meaning that the JavaScript is only loaded in the browser if they're using the browser IDE and they access that function at that moment in time. So there's no preloading of this information that's there. And then you can turn it on or off from within the IDE, and you can even put in hooks so that admins can control it as well. This is the way an extension looks. It's similar to the way you write an extension in Eclipse. You're using an injection, right? You got to have a constructor there. There's going to be an action performed event. This is just a simple action event, and it's going to open up a window that says alert. And then you also then need to write a Java extension class. You use injection to pass in the parts of the IDE that you want. In this case, it's an action manager, a console part, and a hello world action. You register the action, which is basically registering the action from the previous page into the system. You're going to add, this one gets the main menu, right? And then it adds the new action to the main menu. And just for fun, it's going to print hello world to the console. And so the output here is that you can see the hello world action is added to the main menu. It printed hello world in the console. But if you click the hello world item, you get that window alert from the action on the previous page. So it's just that simple, right? And you've got a GUI extension that will drop right in to the system that's there. We've gotten a ton of, obviously we've built a ton of APIs for UI modeling, windowing, managing editors, and managing the server, and those are all available there. The SDK is licensed under Eclipse, EPL 1.0. It's downloadable. We have it on our GitHub page. We also have it, it's going to be going up on the Eclipse page very soon here. We came here today because we wanted to show it off. We're not ready for production. As you saw, we're getting a lot of kind of weird connectivity issues that we've got to work out. But we're looking for new collaborators. We want to work on new programming languages, new builder providers. We have Ant, Make, NPM, and Bower today. We'd like to get Groovy, Gradle, Make going with this system. There's new abstractions we need to do. We want to work on extending OSGI in certain ways. Today, OSGI is really great from a server-side pluggability, but it doesn't extend to the client side. If you want to have dynamic loading and unloading of client-side plugins, there's not a consistent model there. And our SDK only runs on Linux today. We need to do a Windows port of it. We don't think there's a lot of work with that. So we're looking for contributors. The Eclipse project is going to be a big deal. We can make you a contributor to that Eclipse project as well. We've got stickers, we've got T-shirts. We're definitely here to learn and collaborate. So with that, I'm going to summarize. I hope you like what you saw. Obviously, we've got a little bit more work to do, but I think there's a lot of promise on this, and we're going to be working hard on that. So any questions? I'm sorry? Yeah, so his question was what are the minimum platforms are. So the SDK itself only runs on Linux today, but you can actually download our entire cloud now. We have this really nice Puppet-based installer. That runs on CentOS. And so you can run this entire thing behind your firewall, and you add as much or as little hardware on it. Once it's running there, we support Firefox, IE, Chrome, Mozilla, and it also will run on your iPhone, and it'll also run on your tablets as well in that sense. Beyond that, there's very few limitations in terms of what the runners can support. So you can install a very wide degree of builders and runners, even if we don't support it, because the builder and runner system is pluggable. If you wanted to have, say, Mono for .NET, you could plug that in as a runner type, and the runner system is going to be able to execute that for you. All you have to do is you just have to have a way to map the output into this system, and there's three types of output possibilities. There's a pure HTML output, which just maps cleanly. You've got a console output, and so then there are bridges for taking standard error, standard in, standard out directly into this system. And then there is all other outputs, like the desktop output, and then you have to use a VNC bridge to get that. Cool. It's right behind you, sorry.
You mentioned at the start that we would be able to integrate to then be with, say, our own continuous integration system. I was wondering if you could tell me a little more about how that would roughly work.
Yeah, his question was how do you integrate with a CI system like a Jenkins or a Hudson? So the easiest way is to use the SCM system and to use commits and then post-commit hooks on that. That's how most of our early adopter enterprise clients are using that. Beyond that, and we don't have it in this new system, we have in our old system, we have this flexible deployer capability. So what you can do is you can essentially program it to say, when you execute a deploy, take these assets and execute these following sets of commands, and that you can use that to then interface with your CI system and trigger that build. Most people used it to deploy to Google App Engine or Heroku or AppFog and whatnot, but you can use it to trigger that as well. We don't have it here, but we have a partner who's working on a Jenkins plugin. And so to us, if there's a Jenkins build and there's an error at the end of that build, it takes a long time to say, okay, if I need to investigate this, I got to trace back. I got to figure out where did this build come from, what's the branch of the source code. And so you'll spend a bunch, 2 or 3 minutes just getting the traceability so you can set up an environment. And what our plugin will do is it'll just generate those factory URLs at the bottom of every job. And so when you're just looking at the job, if there's an error output, you just click a link and it will recreate an identical environment that Jenkins used to execute that build, and then you can do the edit and whatnot on it. We think we can take that pretty far. We haven't gotten here yet, but we think we can do that in the JVM too, right? You run a Java, you've got a JVM in production, and you get these stack traces, right? Exceptions, stack traces, and errors. We know where the code came from. We know how it was packaged. So all that traceability of what's running in production is all there. So we think we can actually modify that output stream and insert these URLs so that you could just look at it, grab the URL at the end of that exception trace, throw it in your browser, and boom, you've got a developer environment that's ready to go against that as well. So we think we can move development to the right in that sense. Any other questions? Yes, sir.
Is there any plans for allowing collaboration on the same code base from multiple people in multiple locations, like Google Docs?
Yeah, so I didn't demo that here, but it's actually native into the model. So I spent a lot of time talking about the cloning of the environments, but if I took an active environment, I don't know if it's still running, but if I took an active environment like this one, and I were to go into IE, right? Now I'm a second user, right? It's going to load. And so environments, you can first designate it as read or a public or private. Even though it's public, by default, only the administrators or the people with developer rights have read-write privileges. So in this case, it's a read environment. It doesn't know who I am, so I've got read-only privileges. And I can come in here, I can view files, I can edit. I cannot edit those files, but it will, when we're done with this, it'll give you a nice message there and say, hey, this is a public project, you only have read credentials, would you like to request read-write access from the owner? You can get that. If you both have read-write access, then you're both in the same environment at the same time, and you can actually trigger builds off of the same build queue. You can trigger runs off the same run queue. You're sharing the files, and so you're both editing the files at the same time as well on that. So the shared resources are more than just the files, it's all the way through the system on that sense. Anything else? If not, great. It says my time is up. Thank you. I apologize for any of the quirks, but I hope you like what you saw. I'd love to get some feedback from you guys if you can. We've got stickers as well. Take as many stickers as you want. And of course, he's telling me, don't forget to vote. Don't forget to vote for how much you loved this session. That's what you wanted, right? All right, yeah. All right, thank you guys.